Yes.
Okay. Hello, everybody. We're Team UmyZoomy, and we're going to be doing a review of our quantitative literacy, math, and reasoning homework that we've done so far. My name's Jessica, and my teammates that are joining me is Mitchell and Ruby. I'm going to start by asking Mitch first. Can you show us and tell us what you deemed profound about the Universe Zoom app?
The app makes things bigger and smaller by zooming in and out. I am not moving. The Earth is moving. When it comes to the size of Earth, it is like a moon next to Jupiter. Scientific notation makes it easier to write really large and really small numbers.
I see that you picked Jupiter. Jupiter, I had no idea that it was 140,000 kilometers away from us. So that's super awesome.
It really is. I like how you can use scientific notation to write huge numbers in a smaller way.
I know. Could you imagine writing out 8 zeros next to your 10?
No, thank you.
I love that.
Thanks, Mitch. That was a great answer.
Thank you.
Oh, so next, I'm going to ask Ruby, what did you find out about how we move in scenario 1?
I found out in scenario 1, even by sitting down, you can move over 7 million miles per hour.
Really?
Even just by sitting, yes.
That's so fast. How do we not faster than one end to the room to the next?
Faster than the speed of light, actually. Thanks, Ruby. Ruby, can you ask the next question?
Yes.
Is this bar in the way?
No, I just don't know whose question it is.
Oh, it's Jessica's.
Okay.
Abaza.
Jessica, can you explain the Venn diagram?
Yeah, a Venn diagram is a triad circle, and it's often used to present data in a very organized way. Typically, we make a table first, and it contains our independent and dependent variables. And once our table is set up, you can see down here in the bottom, we have this lovely table. And when we inserted a graph, specifically our Venn diagram, into our PowerPoints or whatever, you can see how we've put in our obesity, type 2, and high blood pressure, all based on this table down here. And how we came up with the numbers is over here on the right. We have a set formula for subtracting each group from each other to make our data accurate. So Venn diagrams are just a great way to put a whole bunch of data together and not make it look messy.
Beautiful work. Thank you, Abaza.
Okay, Ruby, did scenario 3 in Excel report 2 mean anything to you?
It did. Most people in my family have either diabetes or high blood pressure, and it showed me that you could have more than one of those if you aren't careful enough.
So you really enjoyed the statistics part of this assignment. Awesome.
Yes.
Very nice. Thank you, Ruby. Ruby, can you ask this question?
It's Mitchell's.
Mitchell, describe the population and sample of the data.
The sample is people with diabetes and high blood pressure. Use the data to put each person in the correct category. By being in more than one category, you are at greater risk. You are more likely to be obese and have other issues if you live in different places.
Good summary of this. You covered that entire scenario from the top to the end. Very good.
Thank you.
Mitch, can you ask the next question?
It's my question.
Let's see. Jessica, how do you make a pie graph.
All right, so again, we start off with a table, and as you see over here, I specifically did body movements and how fast. So earlier we were talking about us moving really fast, even though, like, okay, so the Earth and all that. So this is what this graph is based on, and what I did was I plugged in Earth's rotation, the Earth's orbit, and so on and so forth. And then also I typed in how fast they were going. So when I put in my pie graph, I made sure all of this information was present. And I also used my data callouts so I could see exactly what percentage was in each part of the pie graph. And all a pie graph is a special chart that's divided into sectors, and each sector shows us a relative size of each value. So here in SpacePace, you can see all of my clean data based on this table.
I love how you named your graph SpacePace, and your use of Excel is spectacular. Very aesthetically pleasing. Excellent work. Thank you, Abaza.
Thank you. I'll let Mitch ask Ruby this question too.
Okay.
Ruby, did Emily's mom do the graph in scenario 2 from Excel report 2?
Yeah, I think she did, because in the first graph it shows that Emily did better than the other two bowlers. But then when we redid the graph with the right numbers and stuff, it shows that she didn't do any better than the rest of them.
Oh, I see that. So the first graph at the top, that's the one that Emily's mom could have done. Because at the bottom, it doesn't show that Emily is really much better than the other two. You're right.
Why?
Cool.
What makes those graphs so different? Does anybody know?
So when I did my graphs, I discovered setting I believe it's the y-axis to 0. When we set that to 0, it shows, instead of just starting, so at the top, I think it starts at 50, I believe, and at the bottom, it starts at 0. So now we could see all of the data as a whole instead of just zooming in on like the very top of these.
Yeah, good explanation. Wow, great question. Thanks, Ruby. I like the way you said that Emily's mom made that graph. That's pretty funny, because a mom would have that perspective, wouldn't they?
My mom would do that. So Ruby, what is the average height of the army men in randoms of the street?
The average of the army men is 61 inches, while the random people off the street are around 51 inches, because they're not very tall. So I think the army people want like taller people.
The army only recruits tall people. I believe it.
Because all of them are 61 inches or taller, or like up there.
I was kind of thinking that maybe it was just 9 army people. So if you had army people in a platoon, they usually are separated by sexes. So it would probably be, in this case, a group of men. And then those mall shoppers, what do you say about those mall shoppers, Abaza?
I think there might be some babies and kids in there because it's all over the place. I mean, you've got this little dot here that's like 34 inches, and then here's one up here that's almost like 6 feet tall. So I think that they just watched a bunch of people walk by them and just recorded their height.
Yep. Thanks, Ruby. Ruby, can you ask Abaza this?
How can you ensure the bar graph you are making is accurate?
So earlier we were talking about putting our y-axis set to 0. So essentially, here is another example of that. Clinton and Bush, they had, in this left chart here, it looks like Clinton was doing an amazing job, or maybe a bad job, I think, since it's an unemployment rate. So more people were unemployed during Clinton's time than Bush's years. But here we notice that it starts at 5.17%. And over here on the right, when I set my y-axis to 0, so right here this number was set to 0, now it shows us that really there wasn't that much of a difference between Clinton and Bush's years.
Kind of reminds me of Emily's mom.
Yeah, I'm telling you, biasness.
Thanks, Abaza. Mitch, can you ask the next question?
I think this is.
Unless it's yours.
Yeah, that's his question.
Ruby can ask it.
Discuss the correlation between tightness of the data points about the trend lines.
The points are pretty close together. The Army recruits are much more leveled. The armed people are more similar than the random sample from the mall.
More similar. Good word there. Good descriptive word, Mitchell. Thank you.
You're welcome.
Mitchell, can you ask Ruby her question?
Can your graphs be wrong, but the number and information be right?
Your graphs can be wrong because if you got the right calculations or information, the graphs could be wrong and it could mess up everything. And it wouldn't be like the right info.
So if we decided, like, say we went and took a survey of people, well, how do we know that their answers are right? So if we don't have the right answers, are you saying our graph can't be right?
Yes. Your answers have to be right for your graph to be right.
I guess I'll have to make sure I get accurate information then when I go to make a graph. What about if I make a graph and I think my information's right? What happens if I don't type my data in right?
Then your graph would also be wrong. It would be right for that information.
So
it would be wrong and the information could be wrong.
So could companies use this to lie at their advantage?
Yes.
That's a bummer. How do we know when they're doing that?
You don't.
I guess
do a lot of research, don't you?
Sounds like it. Now I'll always be skeptical of graphs from now on. Always.
Wait till you do Excel 2. You're going to be skeptical of a lot more than graphs.
Oh, God.
Ruby, can you ask Mitch? Oh, I'm sorry. Was that? Yes, that's right.
Discuss the meaning of the changes in the shape of the sleep distribution curve related to the changes in the standard deviation.
People who sleep at a certain amount fall in the normal curve. Depending on how much you sleep, you could be anywhere on the chart. The C-score is 100% to 80%. American income is pretty high. The average American income is skewed to the left. There are always outliers or exceptions.
Great, thanks, Mitch.
You're welcome.
Mitch, can you ask Abaza her next question? Whoa, look at that.
That's a laser gun.
Cool.
What graph is
Actually
used
a
to display and calculate profit?
So I learned how to make a parabola, and this graph you see here over to the left is a great way to present profit. So my lovely picture of Elon Musk over here, he's holding his flamethrower, and this parabola is actually based on his flamethrower business. And over here, you could see where I've got a kind of a meh face. That's where he first started his business, and he had quite a bit of profit. But as he got further into his business, and you see where this line starts to sag down here to the red sad face, he actually started losing money. And it took him a lot of time and frustration before he finally started making profit up here to my green smiley face. And once here, it was smooth sailing up to the pink happy face. So he started making great profit at this point. And I think it only took him 20,000 to start making profit. And after I further researched and watched his video, I later found out that he actually sold them in 3 days. So really, he didn't have that much trouble selling them. I guess there's a lot of tyros in America, and they love the idea of buying flamethrowers.
And everybody loves Elon Musk, and that might have helped. Thanks, Avaza.
So, Mitchell, can you explain how the first data entry on the table and the y-intercept on the graph represent the initial investment?
The initial entry is the startup cost of $12,000. The bottom dollar is the lowest point on the chart when profit is equal to the cost you break even. He has to sell at least 260 to make 90K. Business usually starts slow and takes time to grow.
So I see here your little parabola. It's got the same idea as mine. That's cool.
Mm-hmm. Very nice. Thanks, Mitch. Great answer.
You're welcome.
Mitch, can you ask Ruby?
Did you find it hard to budget with your dream job, and what was hard about it?
I did find it hard to budget with my dream job because police officers don't get paid very much, and every year everything gets more expensive, like internet, TV, and all that fun, exciting stuff. And it was hard because if I don't have enough money to have it, then I can't have it, and that sucks.
Kind of puts you into reality, huh? Kind of makes you step back. Maybe you'll have to do a little extra planning. I didn't know police officers didn't get paid very much. I thought they got paid pretty good.
They don't get paid a
Very
lot.
But another thing I know about police officers is they have opportunities to do a lot of extra stuff. Like I know they get paid overtime, a good amount to work at the racetrack and do security for concerts. So you might have some opportunities to bring in some extra cash here and there.
That'd be cool.
Some police officers work 24 hours.
Oh, wow.
Thanks, Ruby.
What are the 5 values of a box and whisker pilot?
Plot. So here we have box and whisker plots, and that's these graphs down here at the bottom where it shows all right, so I guess I'll explain. Here you see Q1, and that on our chart would be this section here. Our median will be this line here, and then our Q3 that you see right here will be right here out to somewhere to these lines. And we have low values and we have the maximum value. And we just record it based on how we see this line. And also, if we take it a step further, we can see our standard deviation, which shows how thick or thin this line will be. So over here, you can see our standard deviation is really thick for our random mall shoppers, because earlier we said it's just random people. And then over here to the left for the Army heights, we have a thinner line. And that's because we discovered maybe they're all men and they're closely relative. And I just used my math skills to figure out these Q1 and Q3s and our median here.
Very nice. Thanks, Abaza. Great detailed explanation.
Mm-hmm.
I think that might be it for the slides. I think
Well, that was a fantastic presentation. How does everybody feel about it?
I'm just happy to get it off my chest.
Well, good. I'm glad.
I also feel like this was a little better than our first video. I think we definitely needed the practice and some assistance.
Right. And you guys have included a lot of math here. Fantastic job. Super proud of you guys. You guys will just turn your link into Blackboard, and I will see you on Monday or Tuesday.
All
Oh,
right.
yeah. And
How do I?
oh yeah, before I forget, I'm almost finished with this week 6 of stuff, you know, the graphs and stuff. It'll be in before